Hello Math 3 students. In case I forget to tell you this, I've just received an email from Ms. Williams about how you can take a picture of your work and submit that on any assignment that you've been assigned. So if you prefer to take these notes and to do the work on notebook paper, I'm not going to tell you that you can't. As long as you have, well, and it works on an iPhone. So if you have an iPhone and you have the Canvas app on your phone, and if you don't, you can add it to your phone. But if you have that app on your phone, then what you can do is you can take a picture of your work, click share, like and y'all know how to do that, like you would if you were going to text it to somebody or Snapchat or whatever. So click share and then scroll over to the Canvas app, choose your course, choose the assignment, and then click, I think you click submit, but I can send you the directions for doing this. But I know that some of you don't care to annotate these notes, and that's fine. I just want them all to be submitted in the same place. So no matter how you do the notes, that's up to you. I might could give you a physical copy if you're in my class, but if you're not in my class, I just, I'm not going to be able to make copies and have you pick them up and all that stuff. So, either this or notebook paper is going to be the way that you need to do this. So in case I forget to tell you, I wanted to tell you at the beginning of this video so that you know that you can do these on notebook paper and submit a picture of your notes as long as it's on the correct assignment. So as long as it's on the 1.2.3 Wednesday Compound Inequalities notes assignment, then that's fine if you submit it that way. So yesterday we did a little bit with inequalities, and we talked about interval notation, and we're going to continue with that a little bit, but we're going to talk about something called compound inequalities. And compound inequalities are just two inequalities that are joined by one of two symbols, and we did one of those symbols yesterday. I'm just going to write in here because I've got the symbols to put in here, and I can't do that with a text box. So compound inequality consists of two or more inequalities joined by and, so the word and, or the word or. Now, there's also symbols that go with that. The word and has the symbol that looks like this, so it's that U upside down. The word or has the symbol that looks like this. So if you see this symbol right here, you're going to say and. If you see this symbol right here, you're going to say or. Compound inequalities joined by the word and can also be written as, and I'll give you an example instead of putting variables in here. So something like 1 is less than x is less than 3. So a compound inequality joined with the word and might look like this as an inequality. A compound inequality with the word or might be something like x is less than 2 or x is greater than or equal to 10, because you can't be both. You can't have both of those. X could be greater than 1 and less than 3, because right here, this part, this means x is greater than 1. If 1 is less than x, then x is greater than 1. That's not really that important. But x could be both between 1 and, or greater than 1 and less than 3. But it couldn't be less than 2 and greater than 10. So that's why we use that word or. And this is one of those, I'll just show you on a graph. This is one where we had, and we did some of this yesterday, we have our 1 and 3, we have our circles, and then we have that shaded region in the middle. So what that means is x is between 1 and 3. And this one right here, we still have one graph, but we have the 2 here and the 10 here, and then the graph goes away from, the arrows go away from each other. So they look like that. And so this is the word or, this is the word and. Moving on, let's go down and I'll show you a couple of examples. So this example says x is greater than 2 and x is less than 5. So what we could do is we could rewrite this if we flip this part around and we say 2 is less than x, because if x is greater than 2, you see how all I did was flip everything around. 2 is less than x, and then I could also combine these, put the x's together, and write it like this. And again, that just says x is between 2 and 5. And then so the way we would graph that, open circles on both of them. And then I'm going to see if I can be a little bit easier to do this. There we go. Okay, and then this one right here says x is less than 2 or x is greater than 5. So switching these around doesn't help me any like it did over here. So x is either less than 2 or it's greater than 5. So less than 2 is this way. Greater than 5 is this way. So that's how they look different. Let me do my arrows. So less than 2 goes this way, and greater than 5 goes this way. So that's the difference between those two types of inequalities, compound inequalities. The other thing we can do is we can write the intervals here. The interval for this one is parentheses 2, 5, and then parentheses. And the interval for this one, of course, this is negative infinity over here. This is positive infinity over here. So I have endpoints here and I have endpoints here. Of course, negative infinity is not really an endpoint, but it does go in the interval. So this one would be negative infinity and 2. And that's open circle. This would be 5, open circle, and infinity. And we would have the symbol, that symbol right there. This one could be written as, let me think, how do I want to do this? This one could be written as, actually I don't want to do that. I don't want to confuse it. Okay, so let's leave it at this, and we'll talk more about it, about what I'm thinking about in a minute. To solve a compound inequality, I'm just going to give you some steps, and I will type these in. Okay, so step 1, to solve compound inequalities. Step 1, solve as 2 separate inequalities. So I'm going to give you the steps, and then we'll go through some examples. 2, draw three numbers stacked. And I'll show you what I mean by that. 3, graph the 2 solutions using the first 2 lines. And 4, graph the overlap, the word and, or combine if you have the word or on the third number line. Okay, so for example, A. Scroll down. Example A, all those steps aren't necessary, and I'll show you why. Example A is a compound inequality that's not written as 2 different inequalities, it's written as 1. And so the way I usually tell my students to solve this type of inequality is to just do it all together. We could rewrite this as 2 separate inequalities. And don't write this, but you could write this as 3x plus 5 is greater than negative 10, and 3x plus 5 is less than 8, but you don't have to. You don't have to do that. That is the 2 separate inequalities, but it's not necessary. Here's what you do. You solve for the middle, okay? So you try to get x by itself in the center of this thing, and whatever you do to the center, you also do on the left and the right. I'll show you what I mean. So if this was 3x plus 5 equals something, what I would be doing is I would be subtracting 5 first, because it's like a 2-step equation. So subtract 5. But when you subtract 5 from the middle, you need to subtract 5 from both sides also. So my less than symbols stay the same. Just like with simple inequalities, if you multiply or divide by a negative number, you're going to reverse those symbols, but I don't have to on this one. So over here on the left, I've got negative 15. Negative 10 minus 5, negative 15. This is going to be 3x in the middle because that cancels. And then 8 minus 5 is 3. Okay, still trying to get x by itself. So I'm going to divide by 3. And even though this is a negative, I'm not dividing by a negative. So the symbols stay the same. So I've still got less than and less than. So in the middle, I've got the x. On the left side, I've got the negative 5. And on the right side, I've got 1. Okay, so x is between negative 5 and 1. There's a much more complicated way to do this, but we've been doing some like this, so I'm going to leave it like this, like it is. So this is my inequality, my graph. Open circles. And shade between those. My interval notation is just parentheses, negative 5, 1, parentheses. Okay, so this one. This is two separate inequalities. So because I've got the word and, okay, I am going to end up with possibly something between two numbers, or I could end up with no solution. Let's look at it. All right, so let's solve these as two simple inequalities. So I'm going to just split this down the middle, x minus 3 less than negative 4, and then this one over here, and I'm going to change colors for this one. 2x minus 1 greater than 5. So I'm going to solve both inequalities first. Let's add 3 to both sides. X is less than negative 1. And then over here, we're going to add 1. 2x is greater than 6. Divide by 2. X is greater than 3. Okay, I have the word and here. So I'm going to look at this and say x is less than negative 1 and greater than 3. It actually can't happen. But let's look at these on the number line anyway. So what I'm going to do is I'm going to draw 3 number lines. 1, 2, 3. And on all 3 of these number lines, I'm going to put the numbers negative 1 and 3. Because 2 of them are going to be the separate inequalities, and then the 1, I'm going to combine these 2 inequalities and see if I have a solution. So let's do the red inequality on the first graph. Let me go back to my red here. This inequality is x is less than negative 1. Less than negative 1 looks like this. Okay. And then my green inequality is x is greater than 3. So I've got open circle, and that goes to the right because my arrow goes to the right. So that goes that way. All right, so what I'm looking for, because of the word and being here, what I'm looking for is there anywhere that these 2 overlap? Is there any overlap? And when I try to graph the overlap on this third line, there isn't any overlap. What I mean by that is there anywhere that the green and the red run together on these 2? So like if I had, let's say the red instead of where it is, let's say it was, let's say it went this way. Okay, so the overlap would be this part right here. But there isn't any on this one, so I'm going to undo this. There's my undo. So there isn't any overlap. There's nothing where they kind of run together. And so I can't graph anything on this third number line. So my answer is no solution. Oh, I don't like that. No solution. Because there is no number that is both less than negative 1 and greater than 3 at the same time. So that's why it's no solution on that one. Okay, let's look at another one. Okay, so this one is the word or. So it's different if you have the word or. Okay, you combine them. You're not looking for overlap. You're combining the two graphs. All right, so let's still solve these separately. X minus 3 less than negative 4. Add 3. X is less than negative 1. Okay, and then we'll do green over here. X minus 1 greater than 5. Add 1. X is greater than 6. Okay, so this time, though, my word is or. So it could be less than 1 or greater than 6. The word and means that it has to be true. Both things have to be true, okay? So I like to use people's ages, okay? So if I go up here and I say, well, actually, negative 1 won't work for an age, but let's say money. All right, so I have less than negative $1 in my bank account and greater than $3 in my bank account. Well, that can't work. Those two things are what we call mutually exclusive. They can't work together. But if I have the word or, and I said I either have my check, I don't know if my check's gone in yet. So I either have less than negative 1 or I have greater than 6, depending on whether my check got deposited. That could actually happen. Okay, so let's talk about graphing these. I'm going to draw 3 graphs. And you'll get used to this and you won't have to draw the 3 graphs. This is just to illustrate how it works. Okay, on each graph I'm going to put negative 1 and 6. Okay, so let's figure out what the red graph looks like. The red graph is less than negative 1. Okay, so there's less than negative 1. The green graph is greater than 6. Oops, should be right there. Because I have the word or, it's everything that is either here or here. So I can graph this part and this part when I combine them. Do green here. So you remember looking at this type of graph yesterday and writing the interval notation and everything. So we'll do that. Let me get a different color. So the interval notation for this is going to be negative infinity to negative 1. And then I have that U symbol, which means or. Let's see, 6 to positive infinity, and then parentheses. To write these, this is it right here. X is less than 1 or X is greater than 6. That's the inequality. So inequality graph right here. This is kind of the process to get to this graph. Okay, and then this is the interval notation. Okay, so we have one more to do, and again, we have the word or. So we're going to split this in half. 2x minus 1 less than negative 7. Let's add 1 to both sides. That's 2x less than negative 6. Divide by 2. This is a negative number, but I'm not dividing by a negative number. So this stays less than, and it's less than negative 3. All right, let me get green. Negative 4x plus 3. So I'm going to subtract 3 from both sides. Greater than 4. Now this time, I am dividing by negative 4. So I need to flip that symbol. So x is less than negative 1. All right, so let's see what that looks like. Three graphs. And again, you'll get used to this where you're not going to have to draw these 3 graphs every time. And I know this is a lot, but just take it one step at a time. Okay, so on every one of them, I'm going to have the negative 3. And when you draw these graphs, make sure that the right numbers are in the right place. If this was a 3 and a negative 1, the negative 1 would need to be over here, and the 3 would need to be over here. But this is the correct order. Negative 3 is less than negative 1. Okay, so the purple part. That's going to be less than negative 3. So that goes this way. And the green, less than negative 1. And these two, oops, wrong one, this one. These two both go the same way. So they're this way. So what I'm looking for is anywhere that there's both purple and green. So because it could be either or. So where they run together and where they don't run together is my graph. So it's actually from here all the way over, because that includes this graph and this graph. So it's right here. So the solution set, or the solution set is going to be from negative infinity, this is interval notation, from negative infinity to negative 1, because this also includes this part. So the fact that they're both going the same way is kind of weird, but that's just how it ended up. The word is or. If we said and, then it would only be this part right here, but it's the word or, so it's everything that is covered by green or purple. And then the way we would write this is just put the word or. We could put the word or between them, or we could write this as x is less than negative 1. That would also be a correct answer. All right, so that's your notes, and I know it's a lot of different types of problems. Go ahead and you can start on your classwork if the live lesson hasn't started yet, or you can wait for me and work it out with me.